Hi guys, welcome to my YouTube channel. If you're doing your welcome, and if you're old, you're super welcome. This video is concerned with correlation analysis. Correlation analysis is concerned with the measures of relationship between two variables, say variable x and variable y. The coefficient of correlation designated with R is used to determine the degree of correlation or to measure the degree of relationship between two variables. And it is ready to note that the degree of correlation is between +1 and -1. Let's take a look at various types of correlation. We have the first one, positive linear correlation. This simply means as one variable increases, so does the other variable. That is to say that the two variables move in the same direction. Analyzing linear positive correlation results to one called perfect positive correlation. Let's take a look at the graph of linear positive correlation, and here we go. Looking at this graph, we could see temperature against number of ice creams sold, right? Obviously, as temperature increases, number of ice cream sold also increases. So we could see that increase in temperature have a positive connection with the number of ice cream sold. The graph of linear positive correlation shows an upward sloping line. The second type of correlation is one referred to as negative linear correlation. This simply means as one variable increases, the other variable decreases. That is to say that the two variables move in opposite direction. Analyzing linear negative correlation results to one called perfect negative correlation. And so let's take a look at the graph of linear negative correlation. The graph here shows the relationship between temperature and number of coals sold. Alright, looking at this graph, you could see that as the temperature increases, the number of coats sold also decreases. So you could see that increase in temperature have a negative connection with the number of coats sold. This graph shows a downward sloping line, right? The third type of correlation we have is the one referred to as nonlinear or curvilinear correlation. This happens when there is a relationship between two variables, but the relationship is not linear or is not in a straight line, right? So let's take a look at the graph of curvilinear correlation. Looking at this graph, obviously we could see a curved sloping line. The last type of correlation is one referred to as zero correlation. Zero correlation happens when there is no relationship between two variables, right? The graph of zero correlation. Looking at this graph, obviously there is no dictated pattern or dictated relationship between these variables. Methods of correlation coefficients. Remember, we did say correlation coefficient is used to determine or measure the degree of correlation. That is the degree of relationship between two variables. Basically, correlation coefficient is of two methods. We have the mathematical method and the graphical method. The mathematical method is of three types. We have the Pearson's correlation coefficient, the Spearman's correlation coefficient, and also the concurrent deviation. Obviously, we could see that the Pearson's correlation coefficient is of two types. We have the direct method and the shortcut method. But for the purpose of this video, we're going to make emphasis on the direct method of calculating correlation coefficient. And the second method of determining correlation coefficient is the one referred to as graphical method. The graphical method is of two types. We have the simple graph diagram and the scattered diagram. Alright, with this say we're going to concentrate on the direct method of calculating coefficient of correlation, right? And there are conditions for applying the direct method. The conditions are: one, when the x and the y values are small, right, we apply the direct method. And also when their means are integers. This simply means when the means of x and y are whole numbers. So let's take a look at the question we have on the board. Calculate Pearson coefficient of correlation of the following data series using the direct method. We could see the two series. We have series X and series Y and the data attached to each of these series. Alright, the first thing to do is to rearrange this data in a vertical order. And so we've succeeded in rearranging this data series in a vertical order. Steps involved. Step 1 says calculate mean S and mean Y, and here we go. So for the mean S, designated with S bar equal summation X over N, right? Summation X simply means addition of all the S values, right? And here we go, 1 plus 2 plus 3 plus 4 and lastly plus 5, and that gives us equal, we have 15 here over, and of course M simply means number of observations, 1 2 3 4 5, so our M value is 5, and so the mean S will be 15 divided by 5, and we have 3 here, so we record that mean S equal 3, right? We also expected to get the mean Y, so we have Y bar equals summation Y over N. Summation Y simply means addition of all the Y values, 3 plus 5 plus 6 plus 8 and lastly plus 13. And summation Y will have 35 over N. N simply means the sample size, 1 2 3 4 5, and here we have 5, and so 35 divided by, we have 7 here, and so we record that now. So mean Y equal 7, right? Step 2 says generate values for deviation from the means, and this takes us back to our table. The deviation from the mean for the first series, let's call it X minus X mean, right? And remember our mean, of course we are seeing the mean here. Our mean value for the first series, we had 3 here, right? And so let's record that as X minus 3. We'll call that deviation from the mean for the first series X, small x, right? Let's generate value for our deviation from the mean for the first series. So we have the first one, 1 minus 3, of course, that will give us minus 2. Next, we have 2 minus 3. Next, we have 3 minus 3. We have 0 here. And next, we have 4 minus 3. Of course, that gives us 1. We have 1 here. And lastly, we have 5 minus 3. Of course, that gives 2 here, right? Also generate values for deviation from the means for Y. Y minus Y mean. And so we have Y minus Y mean. Let's look at the value for our Y mean. 7 here. The deviation from the mean of Y will represent that with small y. For the first row, 3 minus 7, and that gives us minus 4. So we have minus 4 here, followed by 5 minus 7. That gives minus 2, followed by 6 minus 7. 6 minus 7 gives, we have minus 1 here. 8 minus 7, we have 1 here. And lastly, 13 minus 7, we have 6. Step 3 says, square these deviations and add up their values. This takes us back to our table. So we're expected to square these deviations, right? Get the square of these deviations and add up their values. So for the first series X, because the deviation is designated with small x, right? And so we have X squared. And here we go. First one, minus 2 squared. That gives us 4, right? Followed by minus 1 squared. We have 1 here, right? 0 square, of course, that gives us 0. 1 square, we have 1. Lastly, 2 square, because 2 times 2, we have 4 here. Alright, that same way, we're also expected to get the square of the deviation from the mean of x. So we designate that with y square, small letter y square. And here we go, minus 4 square. Of course, that gives us 16. Minus 2 square, we have 4. Minus 1 square, we have 1. 1 square, we have 1 as well. And lastly, 6 square, of course, that gives 36. And remember, we are asked to add up these values. So for the x square, let's add up 4 plus 1 plus 0 plus 1 and lastly plus 4. Of course, that gives us 10. And we record that now, summation x squared equal 10, right? Alright, we also expected to add up this, right? We have 16 plus 4 plus 1 plus 1 and lastly plus 10. Of course, that gives us 58 and we record that now. And so we have summation small y square equal 58, right? Step 4 says multiply the deviation from the mean of x by the deviation from the mean of y and add up the values. And let's revisit our table. We expected to multiply x, small x, right, by the deviation from the mean of y times y, right? So here we go. Minus 2 times minus 4. We have 8 here, followed by minus 1 times minus 2. We have 2 here. Next, we have 0 times minus 1. Of course, that gives 0, right? Next, we have 1 times 1, we have 1. And lastly, 2 times 6, 12, right? And we also instructed to add up these values, right? And here we go, 8 plus 2 plus 0 plus 1 plus 12. And that gives us 23. And so we record that summation xy equal 23, right? Finally, step 4 says apply the formula to calculate r. Alright, the instruction is to use direct method, right? And the formula for calculating the coefficient of correlation using the direct method goes as summation xy over square root of summation x squared times summation y squared. Alright, going by our formula, we could say summation xy, and we trace our summation xy, we have 23 here, so we have 23 over, following the formula, square root of summation x squared, value is 10, we have 10 here, times summation y squared, and the value is 58, and we record that equal, we have 23 over square root of 10 times 58, we have 580, right? And we have 23 over root 580, we have 24.08, right? And so our r would be 23 divided by 24.08, 0.955. Looking at the value for coefficients of correlation using the direct method, we could simply conclude that x and y indicates high degree of positive correlation. A positive correlation because we could see our r value is a positive number. And so we've done justice by using the direct method to calculate this correlation coefficient. Thank you so much for taking your time to watch this video. And please don't forget to subscribe to my channel, leave a comment, and share this video. Bye.